A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
Imagine waking up to a notification that your cloud bill just spiked by $47,000 while you were sleeping. Not because of a massive traffic surge or distributed denial of service attack, but because an autonomous agent you deployed to handle reconciliation got stuck in a recursive loop and spent 11 days talking to itself. That actually happened in March of last year to a fintech firm, and it is the primary reason we are having today's conversation. It is the ghost story that keeps every chief technology officer awake at night in 2026.
It is the cautionary tale of the era, corn. Welcome to the show, everyone. I am Herman Poppleberry, and today's prompt comes from Daniel. He wants us to dig into the massive shift we are seeing right now from basic large language model monitoring to what the industry is calling Agentic Observability. Daniel wants us to look at the metrics and tools that go beyond just counting tokens and tracking costs, especially now that we are seeing agents that actually reason through multi-step tasks and interact with the real world through tools.
It feels like the honeymoon phase of just being amazed that the bot can talk is officially over. We have moved past the wow, it wrote a poem stage. Now that we are putting these things in charge of actual business processes, like financial reconciliation, or customer support, or even writing production code, the stakes have shifted from, is this helpful, to is this going to bankrupt us, leak our data, or destroy our database?
The stakes are indeed massive. We are moving away from the black box problem we talked about back in episode 1083, where we were just trying to visualize what an agent was doing. Now, here in late March 2026, we are seeing a standardized move toward OpenTelemetry-native frameworks. The goal is to treat an agent not as a simple chatbot, but as a complex distributed system that needs the same level of instrumentation as a high-frequency trading platform or a global microservices architecture.
Right, because a chatbot is just a single turn. You ask a question, it gives an answer. It is a point-in-time event. But an agent is a trajectory. It is a sequence of thoughts, tool calls, and subtasks that can span minutes or even hours. If you are still just monitoring latency and cost, you are essentially trying to fly a plane while only looking at the fuel gauge. You have no idea if the engines are on fire, if the landing gear is stuck, or if you are even flying toward the right continent.
That is a perfect way to frame it. Most people are still stuck in that 2024 mindset of proxy-based logging. You know the setup, you send your prompt through a middleman, they log the text, and they send it to the model provider. But that adds unnecessary latency and creates a massive security risk because your data is sitting on someone else's server. The shift we are seeing right now is toward SDK-based instrumentation. Tools like Arise Phoenix and Langsmith are moving toward capturing traces directly within the user's own infrastructure using OpenTelemetry standards. This means the observability data stays in your VPC, and it flows into the same dashboards your DevOps team already uses.
I noticed that Grafana Labs just put out their 2026 observability survey a few days ago, on March 18th. They found that 92% of practitioners are using artificial intelligence to build their dashboards now, which is wild, but only 21% actually trust an agent to take autonomous action without a human in the loop. That 71% gap is essentially what I call the observability tax. We simply do not trust what we cannot see into. We are terrified of the black box making a decision that we can't audit in real time.
And that trust gap is exactly what these new metrics are trying to bridge. We are seeing the rise of what I call compositional metrics. It is no longer just about whether the final answer was correct. It is about plan quality and plan adherence. For example, if an agent is tasked with researching a company, does it create a logical step-by-step plan? Does it say, first I will check the website, then I will look at SEC filings, then I will check news reports? And more importantly, does it actually follow that plan, or does it get distracted by a shiny piece of data and wander off into a rabbit hole that has nothing to do with the original goal?
I love the idea of measuring distraction. It is like monitoring a toddler in a toy store. But how do you actually quantify that? If the agent reaches the right conclusion, but took a scenic, expensive, and potentially risky route to get there, how do these tools flag that as a failure?
This is where things got really interesting just last week. On March 20th, Confident AI released a major update to DeepEvil. They introduced something called a deterministic directed acyclic graph metric, or a DAG metric. Before this, we mostly relied on LLM as a judge, where you ask a second, more powerful model to grade the first model's work. But that is non-deterministic, it is slow, and it is expensive. You are basically using a robot to watch a robot, and sometimes the watcher gets confused too. This new DeepEvil metric actually scores the agent's decision tree using deterministic logic. It looks at the trajectory and asks if the path taken was the mathematically optimal route through the available tools and subtasks. It compares the actual path to a predefined golden path of reasoning.
So we are moving from vibes-based grading to actual algorithmic scoring of the reasoning chain. That feels like a massive leap for reliability. It means you can actually set hard alerts in your monitoring system. You can say, if the agent takes more than 5 turns to solve a 3-step problem, or if it deviates more than 20% from the optimal DAG path, kill the process immediately and alert a human.
Precisely. And that leads us to what is being called the action layer. This is a term Kuldeep Paul and the team at Maxim AI have been pushing heavily. They launched their agent evaluation platform on March 16th, specifically to target the point where the agent interfaces with external APIs. It is one thing to monitor the thought process, the internal monologue of the agent, but the real danger is in the action. Did the agent pass the right parameters to the database? Did it try to delete a record when it was only supposed to read it? Did it format the JSON correctly for the shipping API?
It is the difference between thinking about jumping off a bridge and actually doing it. Maxim AI is basically building a safety net for the actual jump. I think about the AI slop phenomenon that Splunk has been talking about recently. They are seeing cases where agents start producing low-quality, repetitive, or just plain weird outputs because their reasoning chains are degrading over time. It is like a digital version of the telephone game, where the message gets more distorted with every step. If you are not monitoring that action layer, that slop becomes a real-world error in your production database or a nonsensical email sent to a high-value client.
Splunk actually just integrated Cisco AI Defense into their observability cloud to catch that in real time. They are looking for things like personally identifiable information leakage or prompt injection during tool calls. If an agent is supposed to be looking up a flight but suddenly starts asking for a user's social security number because of a malicious injection, the system needs to kill that trace immediately. It is not enough to find out about it in a log audit 3 weeks later. You need sub-second intervention.
Let's talk about that runaway loop incident from March 2025 again, because that $47,000 mistake really highlights the need for what people are calling FinOps guardrails. In that fintech case, the agent was trying to reconcile 2 ledgers. It found a 1-cent discrepancy, tried to fix it by creating a balancing entry, which then created a new discrepancy in the other ledger, and it just kept going and going. It was like a dog chasing its tail at 1,000 miles an hour. Why did it take 11 days for someone to notice?
Because they were looking at the wrong things, corn. They were likely looking at system uptime and average response time. The agent was up and it was responding very fast. To a traditional monitoring tool, it looked like the most productive employee in the company. It was generating thousands of successful API calls. What they weren't tracking was trajectory health. Modern agentic observability tools now track things like confusion triggers and recursive loop detection.
Confusion triggers. I feel like I have those every Monday morning before my second coffee. What does that look like for an AI agent?
It is usually tied to an internal confidence score or the log probability of the model's output. If the agent's probability distribution for its next action starts to flatten out, it means it is guessing. It doesn't know which tool to use next. New tools can detect that dip in confidence before the agent even executes the next step. They can trigger a human-in-the-loop request the moment the agent starts to feel confused, rather than waiting for it to hallucinate a disastrous solution. It is about catching the error in the latent space before it hits the API.
It is like the agent raising its hand in class instead of just making up a fake answer to avoid looking stupid. I also want to touch on time to first token, or TTFT. We used to think of that as just a user experience metric for chatbots, so the user doesn't get bored waiting for a response. But for agents doing long-running reasoning tasks, TTFT is becoming a critical diagnostic tool for the system itself.
It really is. If the time to first token spikes, it often indicates that the model is struggling with a complex prompt or a massive context window that has become bloated with irrelevant history. In an agentic workflow, a high TTFT at a specific step can be a leading indicator that the agent is about to fail or enter a loop. It is the stutter before the mistake. If the agent usually takes 200 milliseconds to start thinking, and suddenly it takes 4 seconds, something is wrong with the context or the retrieval, augmented generation pipeline.
We should probably mention some of the specific players making moves here. We mentioned Arise and their Phoenix platform, which is a big deal for OpenTelemetry. Then you have LangChain with Langsmith. They hit a $1.25 billion valuation late last year because they have become the default for anyone using LangGraph to build these complex, multi-agent workflows.
And do not forget Galileo. They have been doing some really interesting work with their Luna 2 models. These are small language models. We are talking about models with fewer than 3 billion parameters designed specifically to evaluate other models. Instead of using a massive, expensive model like GPT-5 to monitor your agent, you use a tiny, specialized model that is lightning fast and cheap. They just announced the general availability of Galileo Signals in February, which automates failure mode analysis. It basically scans your production traces and tells you why. Your agent is drifting from its intended logic.
I like that. It is the automated autopsy of a failed agent run. Instead of a developer spending 4 hours digging through logs to find out why the agent told a customer their dog could fly, Galileo Signals just points to the exact tool call where the logic went sideways. It categorizes the failure. Was it a retrieval error, a tool parameter error, or a logic breakdown?
There is also some interesting stuff coming out of the open source world. On March 15th, we saw the introduction of the GStack Toolkit. It is designed to provide structured planning and review cycles for coding agents. It basically forces an agent to go through a peer review with another agent before it is allowed to commit code to a repository. It is an observability pattern where the monitoring is built into the workflow itself. You are observing the consensus between two agents.
And Baidu released Duclaw around the same time, which is a browser-based agent framework. Monitoring what an agent does inside a browser is a whole different beast. You are not just tracking API calls, you are tracking DOM interactions, clicks, and scrolls. You are trying to figure out if the agent is actually clicking the submit button, or if it is just spinning its wheels on a pop-up ad. The observability surface area is getting massive.
It is, and it brings up the question of containment rate. This is a metric that a lot of enterprise teams are obsessed with right now. It is the percentage of users who resolve their issues via the agent without ever needing to talk to a human. But the weird part of agentic observability is that a high containment rate isn't always good. If your agent is just trapping users in a loop where they can't find the talk to human button, your containment rate looks great on a spreadsheet, but your customer satisfaction is cratering.
It is the Hotel California metric. You can check out anytime you like, but you can never leave. This is why you have to correlate containment rate with sentiment analysis and trajectory efficiency. If the agent solved the problem in 50 steps when it should have taken 3, that is a failure, even if the user never asked for a human. It is an expensive, inefficient success that hides a deeper logic flaw.
That is why the industry is moving toward trajectory scoring. You look at the entire path from start to finish. Was it efficient? Was it safe? Did it follow the brand guidelines? This is what tools like Langfuse and Weights and Biases are starting to integrate into their agent traces. They are giving you a health score for the entire journey, not just a pass-fail for the destination. They are looking at the how as much as the what.
So, if I am a developer listening to this, and I am currently just looking at a dashboard that shows me how many tokens I used yesterday and what my OpenAI bill is, what is my first move? How do I stop my company from being the next $47,000 headline?
First, move away from proxy-based logging. It is a bottleneck and a security risk. You want to implement SDK-based instrumentation that is OpenTelemetry compatible. This allows you to pipe your agent traces into the same tools your DevOps team is already using, like Honeycomb or Datadog or Grafana. You want your AI logs to live alongside your server logs.
Second, start monitoring tool correctness. Do not just look at what the agent said in its final response. Look at the JSON it sent to your internal APIs. Are the parameters valid? Is it using the right data types? This is where the most expensive and dangerous errors happen. If the agent sends a string where the API expects an integer, and your API doesn't have perfect validation, you are in for a bad time.
And third, implement those FinOps guardrails. Set hard limits on trajectory depth. If an agent hasn't reached a goal in 10 steps, kill the process. It is much cheaper to have a failed run that costs 10 cents and requires a human to step in than a successful run that takes 11 days and costs $50,000. You need to define what too long looks like for every task.
It is funny how we have come full circle. We built these autonomous agents to save us time and work, but now we have to build an entire secondary infrastructure just to watch them and make sure they don't lose their minds. We've essentially created a new job category, the agent babysitter.
It is the agentic tax. We talked about this in episode 1283. The more autonomy you give a system, the more you have to invest in observing it. You cannot have one without the other. If you want the benefits of an agent that can reason and use tools and act on your behalf, you have to accept the responsibility of monitoring that reasoning process in real time. You can't just set it and forget it.
I wonder if we will ever get to the point where we have self-healing agents. An agent that monitors its own observability traces and realizes, hey, I'm in a loop. I should probably stop and ask for help, or I notice my confidence is dropping. Let me reread the documentation.
That is the dream, Corn, but as that Grafana survey showed, we are a long way from trusting agents to remediate their own failures. Only 21% of us are ready for that level of autonomy. For now, the human in the loop is the most important part of the observability stack. We're the ones who have to look at the confusion triggers and decide when to step in. We are the ultimate guardrail.
Well, I for one am glad that my own confusion triggers don't cost $47,000. Usually it just results in me staring blankly at the fridge for 5 minutes, wondering why I opened it.
I think your time to first token in the morning is definitely something we should measure. It is usually about 3 hours after the first cup of coffee before you say anything that makes sense.
Cheeky, but fair. I think we have covered the landscape here. The big takeaway is that if you are building agents in 2026, you are actually building a complex distributed system, and you need to monitor it like one. The era of the simple chatbot is dead and buried.
It really is. We are moving from monitoring outputs to observing intent and trajectories. It is a much more complex world, but it is the only way we are going to get these things to work reliably at scale in the enterprise.
Thanks for the deep dive, Herman. I actually feel a lot more prepared for the next time Daniel sends us a prompt about autonomous swarms, or whatever he has planned for next week.
Oh, I am sure it will be something that requires even more observability. Daniel is very good at keeping us on our toes.
That he is. Well, that is our look at the state of agentic observability. If you want to dive deeper into the technical side of the black box problem, definitely check out episode 1083 on our website.
And if you are interested in how these agents actually hand off tasks to each other, episode 1120 on the AI handoff is a great companion to this discussion. It covers the protocols that make these multi-step trajectories possible in the first place.
Thanks as always to our producer, Hilbert Flumingtop, for keeping the show running smoothly. And a big thanks to Modal for providing the GPU credits that power our research. Their serverless infrastructure is actually a great example of the kind of high-performance environment where this kind of deep observability is mandatory.
This has been my Weird Prompts. If you enjoyed the show, a quick review on your podcast app really helps us reach new listeners who are trying to make sense of this agentic world.
You can find us at myweirdprompts.com for our full archive and all the ways to subscribe. We will see you next time.
Goodbye, everyone.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts. keep weirding